Thanks for joining me. My name is Yuval Fisher. I'm CTO and most valuable player dude at Imagine Communications. By a lucky coincidence, MVPD also stands for Multi-Video Program Distributors. And I'm going to be talking about OpenStack and TV Everywhere. We all know that these are two technologies that have the capacity to destroy Tokyo. In particular, TV Everywhere is we all know Godzilla pretty well, but Gamora, a little bit more mysterious. TV Everywhere may be a bit more mysterious. I want to start with a few words about Imagine Communications. That's a new name for the company. It's about a year old. Before that, it had been called Harris Broadcast. And about 3 weeks ago, Imagine Communications purchased RGB Networks. And you may see some RGB Networks branding still in this deck. It's a broad spectrum of products that Imagine has, ranging from playout, contribution, primary and secondary distribution, as well as ad management and now ad delivery capacity. And very much focused on now moving those traditionally hardware-based capabilities into cloud, whatever that means. That means SDN, abstracting out, for example, network flows that are both IP and SDI, deployment of ecosystems in the cloud. And I'll show you an example of that. In this talk, we'll go over a specific example. It's like a poster child for a video service provider or an MVPD. So in a kind of a map of a you are here map of the technology sort of abstracted out, you can see on top kind of contribution feeds, a bunch of logos that mean do stuff to video in the middle, and then some distribution. And we're going to be looking at sort of this area where video is distributed to multi-screen devices and sort of the upcoming TV Everywhere capabilities. We'll discuss what that means. So we'll give a bit of background. I'll discuss why virtualization is a good idea, review kind of what TV Everywhere might mean, then go over OpenStack and discuss, what are the strengths and weaknesses of OpenStack for this application, maybe some discussion about private and public clouds, and then we'll have a nice demo. It's got a video, so you want to stay tuned for that. So what is OpenStack? It's an open source computing platform. It manages pools of resources like compute resources and storage resources, network resources. It's open source software. It's got about 127 companies that contribute to it. There's the top 15 companies that contribute to OpenStack. It's got a lot of momentum, and it simplifies the process of creating virtualized deployments, and it can be run obviously on private clouds or public clouds. The OpenStack Foundation has regular surveys, and this is just a capture of that. This is from the 2014 survey with about 506 deployments responding. And you can see the cost savings and feature very, very prominently in the responses as top drivers for adaptation of OpenStack. Interestingly enough, for this particular use case, for TV Everywhere, whatever that means, we'll discuss that in a minute, cost saving isn't necessarily very high on the list because typically, special purpose hardware will perform better than software for specific, very computationally intensive applications. An example of that might be transcoding of content. So taking very high quality content and transcoding it to a distribution format that's bandwidth efficient. That requires a lot of computational power. You can do that better with specialized hardware. You could do it at less power, and you could do it potentially at less cost if your cost is focused on the actual hardware that does the work. But in terms of operational simplicity and overall cost savings, that's not the case. Or at least it's argued in the industry right now. So while cost savings is listed up high, it's not necessarily cost savings in the focus sense, it's cost savings in the broader overall delivery sense. Interestingly, the annoying moving arrow shows that in telecommunications is actually a very small portion of the deployment of OpenStack, and that's been, in my experience, talking to MVPDs. Typically, they're looking at this, but haven't really jumped in yet, or rather they're in the process, they're midair of jumping into the pool. And so this talk is addressed to, well, the general audience that enjoys infotainment, meaning stuff you know about told in a drab way, but also telecommunications executives who are thinking about whether cloudificationism is a good thing to do. So why should we virtualize these things? It's not the 1990s. I'm not going to even give a reason for why we should virtualize. I think that's sort of obvious. So that's the end of that. So what is TV Everywhere? So maybe in order to understand TV Everywhere, we have to look at the word itself. It's basically two separate words, TV Ev and Reware. What do these words mean? I don't know. It's a mystery, and that's why so is TV Everywhere. It kind of whatever you want, by the way. Thanks, Jack Handy. That's a rip-off there. Really, so what is it really? Well, it's sort of a mobile thing, right? You want to get your video on your mobile device. It's got some multi-screenness to it, right? You can sit and watch your TV on your plasma or LED, big widescreen TV, while at the same time watching something else on your iPad. It's got some place and time shifting so that you can watch your videos whenever you want, wherever you want. Actually, the dirty secret is that it's a very well monetizable service, right? And that's the stuff that we don't think about as consumers, but we're getting monetized either through a subscription service or more so through ad revenue, and it's video provider-ish, meaning your video service provider, your Comcast or AT&T are providing this TV Everywhere service. So to be more precise, we'll say that TV Everywhere is sort of these kind of applications. There's some transcoding that goes on, there's ad insertion that goes on, and maybe delivery of video, maybe VOD, movie content, and or maybe cloud DVR, right? So that you can record your programs in the cloud, save them in the cloud, and then have them delivered on your device as you want. So we'll say that this is what TV Everywhere, and we'll focus on these types of applications. And the example that I'll show later, we'll actually look at an ad insertion ecosystem and how that can be deployed very easily, just as a poster child. All these things can be deployed, of course, very easily in OpenStack. So what do these applications need from a cloud? What are the kind of salient features that you want to have? So don't ask so much what the cloud can do for you. What can you do for the cloud? Not so much. What can the cloud do for you? Well, there's a lot of traffic, right? Not too bad, on a typical service provider with, let's say 100 channels. Not that there are any. Nobody actually has 100 channels exactly. They either have like 600 or 40, but 100 channels, maybe 20 gigabits per second in, maybe a gigabit per second out. It's definitely manageable, but it can be slightly challenging if you have to ride around. A lot of storage. You have to have a lot of storage. There's something called the Cablevision ruling, which manages copyrights. It has to do with copyrights of content, and the bottom line is that if you record your content in the cloud, you need to have a private copy that's your private copy. You can't serve different people from the same copy. So roughly speaking, at 4 gigabytes per hour of storage, that's not a lot, right? You can have many hours at 4 gigabytes per hour, but if you have to do that for 1 million subscribers, each one has to have their own copy, right? If it's the same show, that becomes quite a lot, and you get into many petabytes right away. So there's definitely a lot of storage and a need for storage management. And you want to be able to scale resources with the usage, right? So that means both kind of throughout the day. Maybe sometimes some parts of the day have more load. It also may mean that as your service increases, you want to be able to elastically scale the service that you're providing and the investment that you have in that service. And you want to make it very, very easy to do, right? You want to be able to deploy things in a very, very simple way, just for example, testing or events that come and go. It's very convenient if you can push a button, have a whole ecosystem come up, push another button, have it go away when you're done. So that's basically abstraction of compute, network, and storage capabilities, and that's kind of what OpenStack does. OpenStack, roughly, highly speaking. So, by the way, I'll show you an OpenStack. Stay tuned for the later part. we'll just run through a little demo of OpenStack actually running a screen capture. So that'll be very exciting if you don't know about OpenStack. If you do know about OpenStack, a little less exciting. The strengths of OpenStack, quite easy to use, though. If you remember in the beginning, I did show Godzilla. Initially can be a little bit frightening. At the end, saves the world. It does provide GUI and RESTful APIs, and it's definitely an excellent tool for deploying these complex applications. There are some weaknesses to OpenStack. In particular, a lot of the network model often involves routing things through a single network node. That is not something that you want to do when you're dealing with lots and lots of video that's coming in from multiple sources and getting distributed to multiple sources. So that's a weakness, that's a problem. The inherent capabilities of OpenStack's software-based load balancing are limited by the fact that it's software-based, and that has certain limitations. And support for orchestration is weak. By orchestration, I mean kind of scaling up and scaling down. So TV Everywhere services, for the most part, let's say you're watching video on your iPad, that's a unicast service. When there are more people watching, you have to have more unicast streams. When you have more unicast streams, you need more servers to serve those unicast streams. So you won't be able to scale up your servers when you need them, when more people are watching, and scale them down. That support is somewhat weak in OpenStack. But there are ways to get around all these. For example, you can create a separate kind of hardwired multicast network to deal with your video. You can use hardware-based load balancers when you need to, and you can write a simple orchestrator yourself, and I'll show you an example of that. So next, you might say, well, okay, I'm sold. I'm going to use OpenStack. Should I run on a public or private cloud? It turns out that video service providers, just generically speaking, are afraid of the public cloud. That's largely because they really don't want to have their quality of experience be based on service level agreements. Not that there are good service level agreements generically. If you're running your service on Amazon, it's mostly best effort. Best effort isn't good enough when you are serving video to paying customers who are then going to call you up and complain if there are issues. The other issue is, of course, control of the video content. There may be solutions to that. There may be advanced technological solutions to that, but the reality is that it's kind of the crown jewels, and there are various rights about who can where you can distribute the video, and having it go off-prem can be quite a problem. So mostly private. Mostly these are private deployments. Still have the value that OpenStack provides, but in a private environment. But sometimes you can go to burst out to a public cloud and still maintain quality of experience. And if there's time, I'll discuss that at the end. So let's take a look at a demo of this running. What I'm going to show is here's just description of before and after. It's a lot of stuff here. We won't get into too much of the detail, but we'll start off on the left with just a video feed. We'll watch it, and after just a small number of minutes, so we'll actually see this running, we'll have a relatively complex ecosystem up that actually delivers targeted ads to users. Okay, so this is an OpenStack dashboard. What you see is this is the before shot. We're showing you the resources that OpenStack uses. If you look on the left, you'll see somewhere it says Imagination Solutions. That part is an extension, but everything above that is pretty generic OpenStack. It's multi-tenant. It's a multi-tenant environment. We're going to switch to a different tenant now. That's a lot of value right there, especially because you can imagine one tenant is your deployment, another tenant is your test infrastructure, another tenant is my copy because I want to play with the latest version of the software. So here we have a view of the network topology, and right now we have one ecosystem running. Each vertical line there is a separate network. So you see the blue line on the left is a public network. There's a software-defined router and load balancer connecting that to the orange network, which is now hosting an ecosystem which has got components. Some of them are called PSs, and some of them are called AWs. They're called AWs because awe. We're looking now at a specific instance of a virtual machine running this thing called an AW. It's an ad workflow engine, and you can see there highlighted the specific resources that uses. Okay, so now we're going to also point out here the the separate multicast network, and that's where we ingest video and then distribute it. These PS thingies actually do ad insertion, and they do unicast ad insertion. They substitute ads for specific users, and sometimes you need more of them, and sometimes you need less of them. So this is the extension part of OpenStack that we've done. It allows you to look at the ecosystem. You can see here, this is the ecosystem or an ecosystem that we could launch. It's got 2 OS that run redundantly. It's not so much important what that is, but what you see is that it's a relatively complex ecosystem with lots of nodes on the right, and on the left, there's parameters that, when you launch this ecosystem, connect the ecosystem to the outside world. This tells you how do I connect my little world to the outside so that it's functional. This is what an OpenStack template looks like. So now we're going to go off and we're going to look at a couple of things here. There's a few repositories that we've created here to make this friendly, and this is something that you'd want to be able to do. One of them is the ability to load up configurations. In this particular case, the configuration is, you can see it's highlighting a URL there. I'm not sure if you can read it. It looks to me like you can't. So just take my word for it. It's a URL of source content. The next thing that you might want to do is a rule that tells you how to orchestrate, how to scale up and down your resources. And you probably can't read that either, but there's a very simple rule there that says, I want to scale up if the number of users that I have is more than the number of servers. So this is a demo orchestration rule. I'll set up a whole server for every single user. Do not deploy this way. It is the route to bankruptcy, but it is a route to a more compelling demo. So now we're going to launch the stack. We're going to see it run. And we've selected our configuration. So when this launches, it'll be configured. It'll just go. Now we're going to select our orchestration rule, and we're selecting one called one. I can't even read it, but it's 1 session per PS. So one server, one ad insertion server per user per session. And we've called this demo. And these are the parameters that we saw before floating around on the left side there. These are the parameters that connect up the ecosystem to the outside world. And in particular, one of them, for example, here, is the ad decision server. This is how we connect to an ad decision server to actually make ad decisions. The point is that you could connect to any ad decision server there, and when you launch it, it'll all work. It'll serve out ad decisions. And so now we're launching. You can see the little wiggly bar there moving along. The arrow is kindly pointing that out to us. And it's launching up, and we'll take a look at it. The whole thing comes up in just a couple minutes. So the torture won't go on. It'll be over soon. Look, we've looked at the network topology. We've already come up with a new one. The old one that we saw is still there. It's green now. It's no longer orange. But there's a new one called demo, and it's orange. And it's already got the OS already up. And there's another node called the PS, which is the server that's going to serve. It's a playlist server that serves ads to clients. And now we're logging into the VM to just see it. You can see that's a standard Linux boot screen. So the whole system is just coming up. It's all getting instantiated. So what's happening now? The VMs have been provisioned. The actual services are deployed on each VM. The software-defined network that defines the new network, the orange one in this particular case, has been defined. A load balancer and router into that from the public network to this new network has been defined. That's all SDN defined. And then the post-install configuration has been applied. So the whole thing comes up, and it's all running. This picture is a view of the number of playlist servers that are running using a funky orchestration rule that makes them go up and down, so we can see them go up and down and up and down. The one that we're running, called demo, doesn't have anything yet, so we have to wait for it to still come up. It'll be up in just a second. We're going to now just connect to the actual underlying ecosystem. It's not so important what that ecosystem is, though in this particular case, I said it's an ad insertion ecosystem. It's new, so browser didn't know about it. And we have a virus. Sorry, YouTube. No, that's not a virus. So we're just logging into this. You can see it's still branded RGB. The point of doing this is to show that the configuration's all been applied and everything works. And what we see here is a green arrow, a green little play box that shows you that we have video coming in. That's the configuration file loaded up the video. It's very convenient. And we can actually look at the video. I'm just going to cut the URL out of there and open it up in QuickTime so we can see that there's video actually coming in. And there it is. So that's coming in. It's just pure video coming in. It's got some markers for where ads should be inserted. As it turns out, when we look at this, at the output of this thing, we'll hit write an ad, so we won't have to look at it very long. Another thing to notice is all the pieces are configured. So, for example, we had this playlist server. It's in there. We had the add decision server. If you remember the IP address, I'm sure you all do. It's the same IP address from the configuration, so it's all in there. And now we're going to look at a sample at the output, a sample output. Again, the same way, just grab that, pull it off into QuickTime and play it. I've seen this show before. Gilligan ruins it. They don't get off the island. Oh, sorry, wrong one. We land in an ad right there, so it's not so exciting, but we've landed right into the middle of an ad, so we kind of proved the point. So what have we done? In I don't know, 5 minutes, maybe less, we've done something which a little while ago, actually still today, probably takes weeks. We have to rack and stack, cable, provision the network, provision the management system. I once spent 2 days at a cable provider. I won't say their name, but they're TWC's, their initials, just to get, sorry, well, they're going to go away, and we left Comcast. Just to get IP addresses provisioned, right? So just the software-defined network side of this is a phenomenal improvement. Now we've gone ahead and deleted it. So you see that ecosystem's gone, and when we go and look at the network topology, we'll be able to actually watch it disappear as it gets torn down. You can see there's a bit of orange there, but you can see the orange is no longer connected to the blue network, to the public network. And in just a couple of seconds, both the router and the remaining, yep, they're gone. So the one that was on the right now became orange. Okay. So very quickly, we've done this whole thing. So what are the benefits? Deploy minutes versus days or weeks. Deploy many duplicate ecosystems. Very convenient for labs, for regional deployments. And of course, the separation of resources, especially network resources, via VPNs and multi-tenancies, tremendous advantage. Thank you very much.
Alrighty, what kind of questions do we have? Chris? Anyone? Bueller? You must have done a wonderful job. They're just completely understanding, speechless. So, okay. Well, did you have anything, or should I let it go?
So if we went back to your deployment and everything, the way that you have it all configured so that it could spin up and insert the configuration, can you go over a little bit on how you configured that?
Well, so OpenStack provides a very generic scripting capability. So the value in doing something like this is the ability for OpenStack to create templates that describe the whole ecosystem. And that template process is very generic. And so it allows you to do things like deploy a certain number of VMs, deploy a certain number of resources to each VM, deploy certain software on each of those VMs, network all those VMs, and then you can script write the specific configuration for that specific product, right? So in this particular case, it's an ad insertion ecosystem. We wrote the configuration that says, okay, I have something called an ON, I have something called a PS, and I need to know about each other. And then once I have this PS thing or this ON thing, it reads a certain configuration file, and this is how I apply it. So that's all part of the template, which is a mixture, right? The template is a generic OpenStack capability, but the specific template has to do with a specific ecosystem you want to deploy, and that applies to configuration.